The answer is D, nervous tissue. So we'll start at a gross anatomical level, and we won't actually see these parts of the nervous system in the gross anatomy lab, but they are things that you could see. Beginning at a gross anatomic level, the nervous system consists of the central nervous system and the peripheral nervous system. So it's the peripheral nerves that we'll be seeing, but a lot of this module is to give you the context for understanding the nerve pathways that you'll actually see when we get to the cases. The central nervous system includes the brain and the spinal cord. So these are tender and delicate structures, and both of them, both the parts of the central nervous system, are surrounded by bony cavities. The brain is enclosed by the cranial cavity. The spinal cord lies within the vertebral canal, surrounded by the spine, which consists of vertebrae and intervertebral discs. So when we're born, our vertebral column and our spinal cord are approximately the same length. As we grow, the vertebral column grows much faster than the spinal cord. So the spinal cord stops growing in childhood. The result of this disparity in growth is that the spinal cord is shorter in the adult than the vertebral canal that surrounds it. Also surrounding the central nervous system within the bony housing are three meningeal membranes. The closest to the central nervous system and actually resting right on the surface is the pia mater. So the pia mater, which is right on the surface of the central nervous system, means the dear mother. So she's closely embracing the central nervous system. The arachnoid mater lies outside the pia mater, and this is the spidery mother. So you can actually see on the surface of the central nervous system the spidery appearance of the arachnoid. Between the arachnoid mater and the pia mater is a space which contains the cerebrospinal fluid. Cerebrospinal fluid is circulating throughout the brain and through the central canal of the spinal cord, and then entering the subarachnoid space. It's continuously flowing, it's continuously circulating, and in addition to providing metabolic support for the brain and spinal cord, it also forms a nice hydraulic cushion which can protect the central nervous system in case of trauma. The outermost layer of the three meningeal membranes is the dura mater, which means the tough or enduring mother. And this is the thickest of the layers. This is dense connective tissue. It's adherent to the skull, but not adherent to the vertebrae. And so this is a space, if you require anesthesia for either a surgical procedure or during childbirth, anesthetic can be injected into the space between the dura and the vertebrae, and that's an epidural anesthetic. If a sample of cerebrospinal fluid needs to be withdrawn, it can be taken from the subarachnoid space between the arachnoid and the pia. And as you'll see in a minute, the ending of the spinal cord well above the ending of the vertebral canal provides a useful space where needles can enter the vertebral canal without injuring the spinal cord itself. So the two divisions of the central nervous system are the brain and the spinal cord, and the peripheral nervous system is basically anything that leaves the central nervous system and travels throughout the body. There are two broad categories of peripheral nervous system: cranial nerves and spinal nerves. There are 12 pairs of cranial nerves. Those leave the brain and travel across the cranial cavity through the meninges, taking layers of meninges with them and leaving the skull through small passages. The 12 cranial nerves are supplying structures in the head primarily, and they're numbered from 1 to 12, beginning with the olfactory nerve. In addition to the cranial nerves, there are 31 pairs of spinal nerves. The vertebral column consists of 7 cervical vertebrae, 12 thoracic vertebrae, 5 lumbar vertebrae, 5 fused sacral vertebrae, and a variable number of coccygeal vertebrae, somewhere between 3 and 5. The spinal nerves, part of the peripheral nervous system, leave the vertebral canal between pairs of individual vertebrae. So 8 cervical nerves leave between either the cervical vertebrae or cervical vertebrae and the skull. The thoracic nerves leave between the thoracic vertebrae, lumbar nerves between the lumbar vertebrae, and the sacral nerves come out through holes on both the anterior and posterior surfaces of the sacrum. There is usually one pair of coccygeal nerves, and they're small and they don't do very much. If we look now, instead of an en face view of an anterior view of the central nervous system at an axial section through it, you can see right here, here's the formation of the spinal nerve. And then just as it's leaving the intervertebral foramina, it divides into a relatively large ventral ramus and a relatively small dorsal ramus. A ramus means a branch, and so the ventral ramus will supply most of the body wall and the limbs. The dorsal rami will supply the skin and muscles and sensation from the bones of a stripe down the back of the head and down the back itself. It's kind of like a skunk stripe extending from the head down to the end of the sacrum. All the dorsal primary rami have a segmental pattern of innervation. So they distribute like the stripes on the t-shirt that you can see in this diagram. So the dorsal rami will supply the central portion of the back in a segmental fashion. The ventral primary rami will do the same thing in the front. So the trunk, including the back, will be supplied both sensation and motor innervation by segmental nerves that run around in stripes. There's some overlap in the sensory innervation of these regions. In contrast, the limbs and structures in the neck are supplied through plexuses. There are 3 major spinal nerve plexuses. The cervical plexus is cervical spinal nerves that combine to form a network, and the branches leaving the plexus will have contributions from more than one spinal nerve. So it's basically a backup plan. Instead of relying on input from just one spinal nerve, they receive contributions from more than one spinal nerve. The second plexus, one of the 2 that will be most important to us, is the brachial plexus. And as you know from the introduction, the earlier introduction, the brachium is the arm, and so the brachial plexus will be a combination of spinal nerves that come together, form a network, exchange fibers, and then supply the upper limb. Again, then we have segmental innervation over the trunk. And for the lower limb, the lumbar and sacral nerves will come together to form the lumbosacral plexus. Same principle again. Spinal nerves will enter the plexus, exchange fibers, and the nerves leaving the plexus will have input from more than one spinal nerve. So again, if there were an injury at a particular segment of the spinal cord, there would still be contributions from other spinal nerves that might make up for that. So for your review question, all of the following statements are true except